Please briefly summarize your industry education and professional background.
So I have about 15 years experience in energy, water, and infrastructure, and about 20 years in software. Originally came at this from the investing side. So I was a sell-side equity analyst covering the oil and gas and energy industry. And then I kind of switched sides. So I was a clean tech venture capital investor in early 2007, 2008 timeframe. Prior to that, I worked in startups in the software industry. And after that, I worked in software startups in the energy and infrastructure industry.
So what is your role at Transcend, and how does the company fit within the infrastructure industry?
So I'm the founder and CEO of Transcend. We are generative design software for critical infrastructure. So what does that mean? If somebody wants to do capital planning for any kind of project, water treatment plant, power plant, a substation, data center, really any kind of critical infrastructure project. Today, it's typically a very manual, labor-intensive process, costs hundreds of thousands or millions of dollars, and it takes many months. Typically, you're only getting one or two options in the early project phase. And that's when we make our most important decisions that ultimately drive what this infrastructure is going to look like for the next 20 or 30 years. So Transcend software is used to automatically generate preliminary designs for critical infrastructure, wastewater, substations, and other kinds of infrastructure so that people can make better decisions in the early stages of a project.
So how would you describe the state of U.S. water infrastructure? Is there any particular aspect that concerns you the most?
Water infrastructure in the U.S. is in pretty bad condition. If you look at the American Society of Civil Engineers, I think it gives our drinking water a C- and our wastewater a D+ or vice versa. Chronically underinvested, so people treat water as a public good, and we're never investing enough to keep that infrastructure in place. One of the statistics that always sticks out in my head is there's a water main break every 2 minutes in the US, and in a day, it would fill up 9,000 swimming pools of clean, treated water that's just going out into the street. So we're not in a very good place in terms of the infrastructure condition for water in the US.
Okay, is there any particular aspect of that you think that is most alarming, or is this a general alarm?
No, I mean, I think there's a few, right? So we hear about in the inner cities, the condition of drinking water. Obviously, Flint, Michigan, we've had issues in Newark and in other places. Again, that's this chronic underinvestment. So that's one piece of it. There's a significant problem with PFAS, microplastics that are in the drinking water that we need to remove. On the wastewater side, we are not recycling. And so, you think about the dramatic shift in weather patterns that we've experienced in the Western US with these massive droughts over the past 5 to 10 years, the heat waves and the forest fires that you're seeing there as a result of this. In places in other parts of the world where they've experienced this, they're recycling their wastewater. That's the first source of clean water that you have. So you go to that wastewater treatment facility and you treat it typically for non-potable purposes. 98% of water use is actually non-potable. So it's not water that we drink. We're using it for irrigation. We're using it for cooling, for manufacturing. We're typically using drinking water for that, which is obviously a waste. So if we can recycle our wastewater, then that helps really mitigate a lot of those issues when it comes to the droughts that we're seeing in the West.
What are some of the key and best ways to help improve water infrastructure in the United States and worldwide? Perhaps some ideas that aren't commonly proposed.
The kind of higher level point here is we have to stop chasing our tail. So very frequently, we're seeing that the investment is happening in existing assets and existing infrastructure that we screwed up 5, 10, 15 years ago when we actually designed it in the first place. In the early stages of design, we're not considering all of the uncertainty and all the changes that may come. We're not considering new technologies. We're not considering new regulations. We're not considering climate change, changing weather patterns, and all those kinds of kind of uncertainties. So if we actually start to run more scenarios and designs in the beginning, then we can actually end up with better infrastructure at the end of that process. And that's really what Transcend tries to do.
Can you tell me a little bit about what that would look like, and as far as setting up these designs to be better in the first place?
Here's an example for you. I can give you one in water and maybe one outside of water, right? So on the water side, I might look at, hey, if I wanted to put recycling on this plant, maybe not in the initial phase of construction, but maybe in phase 2, do I have enough room? Am I setting it up from the beginning for that? So that if the weather conditions continue on the path that they're on, I will actually have a source of recycled water. I can then find off-takers for that. That's something I could consider in the planning phases today. Whereas if I was doing it manually, there wouldn't be enough time or enough resources to do that. Another example you might want to think about, again, outside of water, for example, electric vehicles. Not sure if you know this, but electric vehicles typically weigh 50 to 100% more than a non-electric vehicle. So what does that actually mean for the roads that we're designing, for highways that we're designing, and for bridges we're designing, right? And these roads and bridges are going to be there for decades and decades. Today, we're designing them based on calculations that assume cars that weigh much less. So if you start to factor those kinds of things into your scenario planning, you make better decisions, and then you don't have this crumbling infrastructure 10, 15 years from now in the future.
So can you offer some advice to engineers and those working in the water industry, such as utility managers, on what they can do to help the situation and improve their designs and systems?
The first advice I would offer is listen to the operators. So when you're actually doing the design work, it's critical to get feedback from the actual humans who are on site that are going to operate these facilities for the next 10, 15 years. Inevitably, if you talk to those people, they will tell you off the top of their head 5 or 10 things that they absolutely hate about the way that that particular facility was designed that make their life challenging every day. Why aren't we incorporating those things into the initial design in the first place, right? So if you're an operator, speak up, give that feedback to the people that are designing. And if you're on the design side, seek that feedback and then incorporate it into your scenario planning and your capital planning process. You know, another scenario that might be interesting for the readers, you know, we're seeing all these extreme weather patterns all over the US. What does that mean from a water infrastructure point of view? These facilities were never planned to have this kind of wet weather flow and this kind of peak flow. So today we have to look at our existing infrastructure and say, if this trend continues, how do we plan for that in the future? Otherwise, you're going to start to see wastewater plants washing out into our drinking water and surface water streams. This is where software can come into play and really help people look at different options and try to figure out what the cost of those options are and the impact of what those options would be. So I'm sure there's countless other scenarios that your readers can think of. Whenever anybody's doing a capital planning project, there's always 5 or 10 things they wish that they could have explored, but they didn't have the time or the resource to do that. Software can give you the ability to do that.
Off the top of your head, can you think of maybe a couple of those 5 things that often come up that you might be able to help them avoid?
It depends on the asset, right? So if you talk to the person who designed any asset, they will tell you that when they were in the capital planning phase, they were time limited, they were up against a deadline. Usually they're burning like the midnight oil to get these documents over to who's ever going to approve and evaluate the capital budget. And they would have said, I wish I could have evaluated a different weight-bearing load on the bridge. I wish I could have evaluated putting it in that location instead of this location. I wish I could have evaluated recycling. In the case of wastewater treatment, we spend, you know, huge amounts of money to remove nitrogen from wastewater. And yet on the ag side, which is the largest use of non-potable water, we add nitrogen in as a fertilizer to grow food, right? So how about we connect those 2 dots and recycle the wastewater and leave the nitrogen in so that it actually helps from a fertilizer point of view. So these are the kinds of scenarios that people wish they could evaluate in those early project phases, and they can't because they're resource limited today. The only other one I could add is just around the connection to the grid itself for all these renewable assets and all the EV charging stations that we're seeing and all the data centers we're seeing. The big problem right now, and I'm sure your readers have heard about this, is actually connecting them to the grid, which means getting a substation up, running the studies to evaluate what the impact on the grid is going to be. And that's another place where we're seeing software have a big impact. Our software is used to automatically generate preliminary designs for substations and try to shrink that time from when the asset is actually built until it gets turned on, to make it easier for the interconnection to the grid and help, play a role in solving that problem. I think that's another place where you're going to see software play a much bigger role over the next few years.